I've started covering circuit laws by saying we will be able to use these circuit laws to solve this particular circuit. And by solving it, meaning figuring out the voltages and the current associated with all elements. We have 4 of these elements, and what I've done in here is I listed all the circuit variables that we need to find. So for example, for the voltage source, we need a Vs and an Is. And of course, for this particular resistor, we will need a V1 and I1. And for the second resistor in here, we will need a V2 and I2. And for the last resistor in here, we need a V3 and I3. Out of all these circuit variables, we know Vs is 20 volts because it's given to us, because it's the voltage source, but we don't know its current. We don't know any of the other voltages and currents throughout the circuit. So technically we have 1, 2, 3, 4, 5, 6, and 7 unknowns. That means we need 7 equations to solve this particular circuit and find out all these unknowns. And we turned into the 3 fundamental circuit laws, Ohm's, KVL, and KCL, when we wrote certain equations. So Ohm's law gave us these 3 equations, KCL gave us these 3 equations, and our KCL gives us these 3 equations, and KVL gave us these 2 equations. And we said that in KCL case, we have only 2 out of the 3 are independent, so we can technically ignore one of these equations because we can figure out that equation based on the other 2. So I'll just ignore this equation in here. So let's count the number of equations that we have. We have 1, 2, 3, 4, 5, 6, and 7. So we have 7 equations, 7 unknowns. So we have everything we need to actually solve this circuit. So solving these 7 equations will give us the solution for the 7 different circuit variables, but we can make this task a little bit easier by paying attention to the fact that for IS and Vs and Is are not related. However, I1 and V1 are related using Ohm's law. Similarly for I2 and V2 and I3 and V3. So knowing I1, I2, I3 will give us readily V1, V2, V3. So if I just focus my task on just taking a look at equations that will give me IS, I1, I2, and I3 alone, I'll be able to solve the whole circuit. Again, because Vs is known, but V1, V2, V3 we can figure out just using Ohm's law. So looking here, KCL is already written in terms of currents, but KVL is written in terms of voltages. So if I substitute these values of these voltages in here, I will convert KVL equations into equations using currents. So let me just do that for the first equation, which is KVL in here. So you'll see that it's simply negative V1, while V1 is simply negative 2.5 I1. And then plus V3, which is 5 I3, negative 20 equals 0. Similarly, I can use this equation in here, okay, and I can rewrite it using Ohm's law. So V1 is simply negative 2.5 I1 plus V2, which is 5 I2, plus 20 equals 0. So now what I have is the following. I have this is equation 1, 2, 3, and 4, and these 4 unknowns, 4 equations. Then we can basically figure out everything that we need in the circuit. So I'll go through the solution using one of the straightforward and just structured method, which is Cramer's rule or Cramer's method. So I have 4 equations for unknowns. So Cramer's method tells me let's rewrite these equations so that each one of the 4 equations list IS, I1, I2, I3 in order. So let me just do these in these equations. So for example, the first KCL equation in here, I can rewrite this as simply as I of S minus I1 plus 0 I2 plus 0 I3 equals 0. And I can focus on the second KCL equation in here. And the second equation tells me it has 0 I of S plus I1 plus I2 plus 0 I3 equals 0. Or actually it's not 0 I3, it's actually negative 1 I3 because I have an I3 on the other side, which is negative 1 I3 or just negative I3. All right, so the KVL equations or the equations we use that we're generating using KVL will need a little bit of cleanup and reorganization. So let me just do that. So for I of S, that will be 0 I of S. And then for I1, that will be plus 2.5 I1. And then for I2, that will be 0 I2. And then, of course, 5 I3. And that should be 20 on this side. So basically, we move this to the other side. All right, the last KVL equations is simply 0 IS negative 2.5 I1 plus 5 I2 plus 0 I3 equals negative 20. So Cramer's method tells me like, okay, you organize all these equations, you can rewrite them in terms of matrices. So you can take the factors or coefficients of IS, I1, I2, and I3 in each one of the rows and just write them. For the first equation in here, this one here, that will be 1, -1, 0, and 0. And for the second one will be the second one in here. Okay. That will be 0, 1, 1, -1. And the third one, that will be 0, 2.5, 0, 5. And the last one in here, of course, I removed the 20 by mistake. All right, so that will be 0, -2.5, 5, and 0. And it tells me that will be I of S, I1, I2, I3. And that will be equal to the numbers that we have here. And that will be 0, 0, 20, -20. So if you remember your matrix multiplication, you should be able to use matrix multiplication to generate all these equations. So how does Cramer's method work? Cramer's method tells you that you need to compute the determinant of a certain matrices. These matrices are the following. And you can skip this exercise if you know how to solve the Cramer's method already, or do you know how to solve these systems of linear equations. So Cramer's method tells me you have to figure out the determinant of this matrix in here, okay? This matrix, and let's call it D, and then you're going to generate another matrix, we'll call it D1. Okay, in this particular matrix, simply you focus on this. If you want the I of S, you focus on this row or this column, and you substitute it with these values. So that will be 0, 0, 20, -20, and then -1, 1, 2.5, -2.5 in here, and then we have 0, 1, let me just rewrite it in here, 0, 1, 0, 5, 0, -1, 5, and 0. And you find out the determinant of this equation, and you can combine both of them to tell me that I of S is simply the determinant D1 divided by D. And that will be the value for IS. And you can do the same thing for I1 by substituting this column with this particular value. If you want I2, you substitute this column with this particular with these particular values. And if you want I3, you just go in here and substitute this column, and you compute the different determinant equations and so forth. But there are other ways to do that using Cramer's method. There's software to do that. The base idea is you rearrange all these equations either into a matrix or into a list of equations. So let me show you one of these softwares. So I went online and looked for a Cramer's method or rule calculator, and I jumped into this website, or got into this website. And my goal while looking for a tool is twofold. First, I wanted something that is free, so I didn't want you to pay for any specific software or buy a specific calculator or a specific model calculator. So this is free at the time of the recording. And the other thing I wanted also is I wanted you not to have any prior knowledge of a programming language or a specific software. So you don't need to know MATLAB or Python, even though you can do all of these in MATLAB and Python and any other program and multiple other programming languages. And this website, while I don't know the website itself, has basically worked. I tried it with a couple of examples and it worked. So I'm going to show you how I used it. So in this particular example, what we have is we have a matrix of a 4x4. So all we have to do is just basically say that we have a 4. And then you set the matrix and you go ahead and you type the matrix. So we have x1, x2, x3, x4. These stands for IS, I1, I2, I3. So I'll go ahead and type it for you. So as you can see, I just basically wrote, this is the first column of the first row that you see here, or column, sorry. And then this is the second one, which are these ones in here. And the B is the one that's different. The B is just the output in here, which is 0, 0, 20, -20. All you have to do is just click solve, and it will give you the solutions. So it gave me the solution in terms of x1, x2, x3, x4, and these are just simply IS, I1, I2, I3. So all I have to do is just type, well, IS and I1 happen to be 4, and x3, which is I2, is -2, and this is 2. Another software or website that you can use is Symbolab. I've used it on numerous occasions where I wanted the integral of something very quickly. You can use Cramer's rule. For example, you can go in here and say, I want Cramer's rule but you won't be able to use I1 or IS and I2. You have to rename your variables into X, Y, Z, and W so that you can actually know it. So for example, this is an example that is given to me when I looked for Cramer's rules in Symbolab. You just click go. It just pretty much explains to you how like basically Cramer's rule, and it gives you all the determinants and tells you like what you need. If you need X, it's dx divided by D. If you need dy, dy by D, and then it gives you all the solutions in here. So now that we know all the currents, IS, I1, I2, I3, we can take a quick look at the circuit, just double check. So it tells me the IS, which is here, is 4 milliamp, and I1 is also 4 milliamp, which makes sense because IS and I1 are the same based on this equation too. And what about I2? I2, which is here, it tells me that it's -2. So technically it is actually 2 in here. So we have 4 coming in here, and then we have 2 coming in here, and happen to be the I3 is 2 milliamps as well. This is what I have. So I have the 4, it gets split into 2 in here and another 2, and then of course they meet here. We have 2 coming in here, 2 coming in here, and becoming 4 in here as well. That makes sense. All right, so what about the other voltages throughout the circuit? All you have to do is just substitute these values in these equations in here, and you'll find out the solutions. So V1 will be simply -2.5 times I1, which is 4, which is just simply -10 volts. And you can find out the other one, which is 5 times I2, which is -10 volts as well. And then V3 is obviously 5 times 2, which is 10 volts.